Welcome to week 12, lesson 10.2, multiplication, area, and volume. So, our warm-up, just some algebra. Tells us to expand numbers 1, 2, 3. So 4x times x plus 3. Expanded is 4x squared plus 12x. 2, you have x plus 3 times x plus 5. That expands to x squared plus 5x plus 3x plus 15, which is x squared plus 8x plus 15. Number 3, 5 times x plus 2 times x plus 7 expands to 5 times x squared plus 7x plus 2x plus 9x plus 14, which expands to 5x squared plus 45x plus 70 . Okay. That's the warm-up. So, take a picture of that. Whatever. In your study of algebra, you may have seen that multiplication of two polynomials can be pictured as area. So you have the this. Believe this was covered in a previous lesson, but you have the multiplication table where they laid out and they label each side of the mini rectangles, and that the area of those mini rectangles sums up to the area of the large one, and that can be proven using algebra also. So what binomial, example 1, what binomial is pictured at the right? And you have So you have 6x squared here, 8x here, 21x here, 28 here. What binomial multiplication? So this is really just, the area of this is really just this side, 3x plus 4, times this side, which is 2x plus 7. Okay, now multiply the binomials. I'll get 6x squared plus 21x plus 8x is 29x plus 28. Same thing as if you add those areas up. So basically volume is the same thing, except there's more, there's a third dimension added. So there's just more, instead of rectangles now, they're boxes that you're adding up. They're, so it's the same principle. Example 2, the length of a box is increased by 3. So you have the length right here, increased by 3. The width is increased by 5, and the height is increased by 6. How is the volume of the box changed? Look, you don't know the length, you don't know the width, and you don't know the height. So label them as variables, they're unknowns. So the volume equals the length times width times height. Well, the length is, now they changed that was the original volume. Now the volume is length, but now you added 3, you're multiplying by the width, which is, you increased by 5, and you're multiplying by the height, which is increased by 6. So now they're asking you, by how much has it increased? Well, what you do is you multiply this out. You're going to multiply this out, and you're going to find that it would be LW plus 5L plus 3W plus 15 times H plus 6. Volume equals LWH plus 5LH plus 3WH plus 15H plus plus 6LW plus 30L plus 18W plus 80. So, or is it 60, 30, 90? Sorry. So, here, notice, you can't combine like terms. Well, so basically what I did is I just FOILed these, multiplied these, expanded these out, and then once I had that, I expanded each term went to this. I distributed the H, and then I distributed the 6 to every term in here. I added them up. Well, I can't add them up because there's not like terms. But now, so this, imagine this is all one value. Once you have the length, the width, and the height, this all goes to one constant, one value, and that's the volume after all the changes were made. So that's the volume of the box after the height length was increased by 3, the height width was increased by 5, and the height was increased by 6. So imagine this all as one volume. And to find how much it increased, you subtract from the original volume. So minus LWH, you'll realize the original values, LWH cancels, and this is how much everything changed by. Yeah. 6. Okay, so problems 1 through 4, problem set 5. So 1, A and B. For A, we're just going to write the multiplication of polynomials represented by the diagram and then expand it by finding the product, to find the product. So here we're given 7u plus 4 times 2u plus 6. And we expand it, we're going to get 14u squared plus 42u plus 8u plus 24, which is equal to 14u squared plus 50u plus 24. I say 24, I write 25. Okay, so then for number 2, same thing. Part A, we have A plus B times A plus C plus D. So for B, we're going to expand it to we're going to distribute the A to each term and then the B. That's one method. So you have A squared plus AC plus AD plus AB plus BC plus BD. Can any of these add up? Can you combine like terms? The answer is no, you cannot. AD plus AD plus BC. And if you're ever wondering where FOIL comes from, if you ever have an interest, I could show you right now. I showed the 7th graders, but you could always find YouTube videos or anything if you want to know where these, methods come from. I may show you at the end if the video is not too long. So 3, that'll be like the summer party or something, So that's part A. And now we're going to just expand it. We have fx plus fy plus fz plus, so we expanded the f to each term, and then the g to each term we're going to, and then the h. So fx plus fy plus fz plus gx plus gy plus gz plus hx plus hy plus hz. So so for A, here we're given a volume, we're given a three-dimensional shape, and we're asked to find the volume. So the multiplication is, so P plus 1, I believe that's a 1, I can't really tell. Yeah, it is. Times probably is Q plus 6 times R plus 4. So you're adding the height, P plus 1 times the width, Q plus 6 times the length, Q plus 6 times the width, R plus 4. And you're going to multiply that out, PQ plus 6P plus Q plus 6 times R plus 4, which is equal to RPQ plus 6RP plus QR plus 6R plus 4PQ plus 24P plus 4Q plus 24. Constant, no constant. P, I have an R, P, no, that's, yeah, no like terms. I believe there's no like terms because you need at least another term in the initial expression that has the same variable as another. So for instance, these are no variable, like that's why these constants, that's why they multiplied. So if there was another term with just a P, then we would be able to combine some like terms at least. So 6PR plus 4PQ plus 24P plus QR plus 6R plus 4Q plus 24. Yep. Okay, so that is the end of this lesson, but I'm going to show you, since it was quick, I'm going to show you guys where FOIL comes from. Where this distributed, it all comes back from the distributive property. So, once upon a time, you may not learn this, your teacher may not told you, may or may not have. So, once upon a time you learned that A times A plus B equals A squared plus AB. And you learned because you distribute this term and multiply it to each one in here. Well, you'll realize that, and I noticed this when I looked at it sometime, and I don't remember when, but I realized it in school, where FOIL comes from. So really, it's the same exact principle. You have A plus B, and you have B plus C plus D, for instance. I'll make them even all different. And it doesn't matter. It's the same term. Let's call this term, there's a few ways you can look at it. But really, for conceptual understanding, we'll consider this, we'll consider A plus B to equal R. It's random. So, this is equal to R times C plus D. And you'll notice, what do we do when we have, it's the same as the simple distributive property. With a single term times two terms, you distribute it. RC plus RD. Well, guess what? Now, why don't we plug R back in? And you're going to see, we'll multiply by C and put it in front because that's how most people are used to saying it. And look, you're given this term. So all we did is substitute, and now you can distribute the C, AC plus BC plus AD plus BD. Would you look at this? If you want to use your FOIL that you've memorized, AC plus AD plus BC plus BD. It's the same exact thing. Boom. That's where it comes from. And that works with any number of terms. You take one term, you distribute to all the rest. Take the other term, you distribute to all the rest. And there you go. That's where FOIL comes from. So thank you guys so much for watching. If you've watched since the beginning of these videos, and I hope you benefited from these. Thank you.